We have been dealing with equations, but now we are dealing with inequalities. So the left-hand side could be different than the right-hand side, and we don't have an equal sign necessarily in the middle. So if we have an inequality, then we can have something that the left-hand side is greater than the right-hand side. So for example, 5 is greater than 2. So you think of the crocodile. Crocodile is pointed to the bigger side. In this case, this is, I learned this, I'll write it over here, as this, where it's kind of flat, but the left-hand side can be greater than or equal to the right-hand side. So it's possible that 7 is greater than or equal to 7. So 7 counts. But of course 10 is greater than or equal to 7. In this case, the crocodile is pointing in the other direction. So we have the left-hand side is less than the right-hand side. So 2 is less than 10. But in this case, the left-hand side is less than or equal to, and I'll write it again, less than or equal to. It could be 5 is less than or equal to 5, same number, it counts, or 2 is less than 5. So you can flip them around too. Inequalities can be reversed, whereas 3 is less than x, and x is greater than 3. They make sense, because here's the crocodile pointing to the larger of the two. Inequalities can be represented on a number line, and that's what we're going to do, using closed circles at the endpoints if the value is included, and open circles if it is not included or excluded. So if we look at here, x is greater than or equal to 5, then that is closed. So 5 is a contender, where in this case, x is less than 6. 6 is not an option. So the open circle indicates that 6 is not included. A range can be represented as a segment. A segment is where you have a beginning and an end. Like these ones, they go on forever. Go on forever, that's the line. But a segment has a beginning and an end point. So we'll look at all these options down here. So represent the following on the number line. X is greater than or equal to 4. So we'll draw a number line. Greater than or equal to 4. So I'm thinking we'll put 4, 5, 6, so on. So if it is greater than or equal to, that means that we're going to include 4, and x, whatever it is going to be greater than. So x has the option of being 4, otherwise it's going to be greater than. For this one, x is less than 6. So let's take 6, 5, 4, 3. So x cannot be 6 because there's no equal to there, but it's going to be anything less than 6. So it can be 5.9999999 infinity, but it cannot be 6. And for this one, this is a little bit cheeky. So we've got here 1 is less than x. Let's put 1 on here. Let's put 0 for fun. And 2, 3, 4, 5, and 6. So here is where we use a segment. So 1 is less than x. It is not equal to open circle. And x is less than or equal to 5. So it could be 5. So we're going to color that in, and then we're going to connect these. The best connection. Because it could be 5, because it's less than or equal to 5, it's going to be in the range between 1 and 5. 1 is not possible, but 5 is absolutely possible. Describe the following using x to stand for the unknown. So Fred is now x. So Fred is shorter than 160. So Fred, we've been told that Fred is x, is going to be shorter than, less than 160. Shorter than, less than, we win. John is at least as old as Maria. So John could be equal to Maria, who is 10. So is at least as old as 10. So he's going to be 10 or more. So John is equal to or greater than Maria, who is 10. So Rosie's test score is between 40 and 50. And the word inclusive means that we are actually including the 40 and the 50. So 40 is less than or equal to x, and x is less than or equal to 50. That gives us a test score that's between 40 and 50 and includes both the 40 and the 50.